Since 1967, Stroud Water Research Center has focused on one thing: fresh water, by advancing knowledge and stewardship of freshwater systems through global research, education, and watershed restoration. Learn more at stroudcenter.org.
An entomologist is a scientist who studies insects. Insects on land or insects on water. In my case, I study insects in water. I chose to be an aquatic entomologist as a way of understanding water and watersheds. In other words, it's not about the insects for me, but rather they are the tool that I use to understand the stream and tell the story, the scientific story of the stream.
For Dr. John Jackson, this section of southern Pennsylvania's White Clay Creek is as much a laboratory as it is a stream. What he finds under a rock may hold the key to healthier water. Simply put, when it comes to our future drinking water, the buggier, the better.
What we have right here is a water penny coming out. He's called a penny because he's kind of penny-shaped and penny-colored, but his legs, his head, his gills, they're all underneath, and he's moving because we took him out of the water, and he's trying to find his way back to water. Oh, so we have mayflies on this rock. Mayflies are probably our most important pollution indicator. There's a lot of them. So this stream has over 50 species of mayflies in it. So when they're there, you know you have relatively clean water, and when they're not there, then you know you have a problem. And then the question is, what's the problem and how do you fix it? What we have in many cases now today are pollutants we can't see. There are chemicals in our waterways that we can't see, and I can't show them to the public. So instead, I sample the invertebrates, I sample the insects, I let them sample the water.
Just a little upstream from where Dr. Jackson is checking on insects, research technician Laura Sklejewski is preparing to check on the health of the fish in White Clay Creek. To do that, she'll use a method that's a little shocking.
Electrofishing is the method that we use to collect fish from the stream. It's basically a large backpack that's battery powered, and it has a probe that we hold in our hand. It puts a gentle electric current into the stream, and it temporarily stuns the fish. The purpose of electrofishing is to give us a method to quickly and safely for the fish collect a large number. When we look at the whole community of fish that we've caught, we can compare different streams to each other. We can look at an individual stream and figure out where the fish are living in the stream, who's there, who's eating who. Is this a healthy stream in terms of the diversity and the number of fish and the particular species that we've caught?
One of the biggest threats to a healthy stream and the insects that live in it isn't necessarily from industrial pollution or animal waste. It's actually from our own sun, a problem known as thermal pollution.
This is 5 degrees warmer than where we were upstream in the forest, and we're only 300 yards away.
When landowners mow down the vegetation that borders a creek, the lack of shade causes water temperatures to rise rapidly and poses a threat to the insects and fish living there. But that's not the worst of it.
There are two things that happen when a stream gets too warm. The first thing is anything that requires cold water is going to struggle in that system. It may be that they have to leave, but one thing that's often unrecognized is as we warm up a waterway, any other pollutants in there may become more toxic. So if the stream is normally 60 degrees in August or September, and we warm it up to 70 or 80, in the process of doing that, other toxins that may be in that waterway, their toxicity could double in just that increase in water temperature. Whether you're in the Delaware River or in the Chesapeake Bay, you're looking at water that came from small streams like this and fed its way down. And what we do here matters downstream.
Scientists who study the watershed like to say that we all live downstream, meaning that what one person does to the water will ultimately affect all of us.
So our goal as scientists is to make sure that every inch of every stream is fishable, drinkable, and swimmable. We've made huge progress in the last 25 years. We know so much more about how streams behave and how to keep them healthy. We can keep streams cool so that wildlife thrives. This is a very exciting time to be working with water, to be doing the science of water.